Welcome to The Explainer. You know, if hearing the phrase artificial intelligence makes your stomach drop just a little bit, you are definitely not alone. For decades, the whole concept of AI has been this massive source of anxiety for so many of us. But today, we're going to completely demystify it. We're going to break down exactly what this technology actually is, how it really works behind the scenes, and what we actually need to be paying attention to moving forward.
So let's dive right in by challenging some of those dramatic movie tropes we all grew up with. I mean, for the longest time, our cultural understanding of AI was shaped almost entirely by Hollywood blockbusters, right? We literally pictured these self-aware, evil robots actively plotting our downfall. But when we take a step back and look at the AI sitting right there in our pockets today, we really have to ask ourselves, are we actually building a sci-fi villain here, or is this whole thing just a really, really fast calculator?
Section 1. Sci-fi myths versus reality.
If you look back at Hollywood's version of AI from those 1990s movies like The Terminator or The Matrix, we always see this malicious entity actively turning against humanity. And honestly, for almost 20 years after those movies came out, AI made very little real-world progress anyway. But today, the reality is entirely different and significantly less cinematic. Reality's AI doesn't have a glowing red eye. Instead, it's that invisible software silently approving your bank loans, recommending the very next YouTube video you're going to watch, and curating your social media feeds. It's already working in the medical field diagnosing diseases, and it's making split-second decisions in the stock market every single day.
Now, if you've been feeling a little uneasy about all this rapid integration into our daily lives, your feelings are completely valid. Even some of the most brilliant minds of our time have felt the exact same way. The late physicist Stephen Hawking and Elon Musk have both openly warned about the potential dangers of uncontrolled AI. So those fears, they're rooted in a very real awe of what computers might eventually become. But to understand if we should truly be afraid right now, we really need to understand how these systems actually think.
Section 2. How machines learn patterns. Okay, so the crucial point here is understanding the actual leap from a standard computer to an AI. Think about a regular calculator. A calculator is amazing, right? It can multiply massive numbers instantly. But it is just blindly following our exact predefined instructions. If it encounters a situation we didn't explicitly program it for, it completely fails. An AI, on the other hand, does something fundamentally new. It learns from data. It recognizes patterns on its own without us having to hand it a specific rule for every single scenario it might face.
And this brilliantly illustrates how that learning actually works in practice. Let's say we want to train an AI to identify a bird. We don't sit there and write a million lines of code describing every single bird on Earth. Nobody has time for that. Instead, we define unique features and assign them a mathematical weight. Notice how we might break it down. Feathers get a 30% weight, wings at 30%, a beak at 20%, and 2 legs at 20%. So if we showed a picture of a crow, it scores a perfect 100%, and the AI mathematically says, yep, that's a bird.
But here is where the actual learning happens. What if we show the AI a penguin? Well, a penguin's wings kind of look like arms, and its feathers aren't exactly obvious. So the AI might only find 40% of the features and confidently declare, nope, not a bird. When it fails like this, a human steps in and corrects it. The program then goes back and actually adjusts its own internal weights. Maybe it lowers the importance of visible wings and raises the importance of a beak. It basically tweaks its own math, and then it tries again. Every single mistake, followed by a human correction, refines its internal parameters.
I really want to emphasize this key takeaway, though. For the AI, a bird is literally just a group of numbers. It does not look at a picture and experience the concept of a bird. It has absolutely no idea what a beak actually does in the real world. What a human understands when they see a bird is fundamentally different from what the AI sees. The AI is simply crunching weight values and probabilities based on the data we fed it, and that is literally it.
Section 3. Weak versus generative AI.
First things first, we need to clear the air about something called artificial general intelligence, or strong AI. This would be a system that can learn anything, adapt to any random situation, and make broad logical decisions just like a human being. It is basically the holy grail of computer science, and it is also the entity we almost always see in sci-fi movies. But here's the reality check. It does not exist. It is a completely theoretical concept, and experts are still totally divided on whether it will take 20 years, 50 years, or even longer to actually create.
So what do we have right now? Well, it's divided primarily into weak AI and generative AI. Weak AI, which is also called narrow AI, is practically everything we've used up to this point. It performs one highly specific trained task, like spotting a face in a crowd or identifying our bird from earlier. If you ask a bird identifying AI to tell you if an animal is a mammal, it will fail completely. You'd have to build a brand new AI from scratch to do that. Generative AI, on the other hand, think of things like ChatGPT or Google Gemini, takes those learned patterns and uses them to create entirely new content. It can write a novel or generate a hyper-realistic image of a landscape that has never actually existed.
Now, you might be wondering, why did this suddenly explode everywhere over the last few years? Well, it all comes down to this timeline. Back in the 1990s, computers simply lacked the processing power to run complex AI. It just wasn't possible. By the 2000s, processing speeds had increased by thousands of times. And then came the 2010s. This is when the explosion of social media provided actual mountains of training data. Every single time you tagged a photo of your dog on Facebook or wrote a slang-filled comment online, you were actively providing the massive amounts of data these algorithms needed to finally start recognizing complex patterns in human speech and imagery.
Section 4. Real risks. Bias, not brains.
Because AI learns from these massive datasets automatically, it can actually make some bizarre, highly consequential logical errors. Take what's known as the snowy wolf mistake. Researchers trained an AI to identify animals, but it kept misclassifying regular dogs as wolves. When they dug into it, they realized the AI wasn't even looking at the animals at all. In the training data, almost all the pictures of wolves just happened to have snow in the background. So the AI learned that snow equals wolf. It literally assigned more mathematical weight to the snowy background than to the actual animal.
And this leads us to a huge issue that developers call the black box problem. You see, training is handled automatically by powerful software because humans obviously can't manually process millions of images ourselves. But by the time the AI is released, even its own creators often don't know exactly how it is weighing its decisions. It's incredibly difficult to track the internal logic that leads to a mistake like the snowy wolf. This is exactly why there is a massive push right now for transparent AI solutions, which aim to make the AI's internal decision-making processes actually visible and interpretable to us humans.
Now take that snowy wolf logic and apply it to actual human lives. A real company used AI to shortlist candidates for job interviews based entirely on their historical hiring data. But the AI ended up exclusively selecting male candidates. Why? Because historically, the human managers at that company had preferred hiring men for that role. The AI simply looked at the historical data, found the pattern, and mathematically concluded that being male was a heavily weighted requirement for the job. Our own historical human biases transferred directly into the AI's math.
Which brings us to this absolutely crucial core truth. When an AI makes a mistake, it has no idea that it made a mistake. It does not know what is right or wrong. It feels zero regret. It lacks consciousness entirely. And because of that, the responsibility to monitor its behavior, to check the training data for fairness, and to decide what is socially acceptable rests 100% on us, the humans.
And that human responsibility becomes incredibly urgent when you look at how AI is actively being weaponized today, like with deepfakes. Deepfakes actually work by pitting two specialized AI systems against each other. System 1 attempts to swap a famous person's face onto another body. System 2 is basically a detective AI, trained entirely to spot artificial flaws. When System 2 finds a flaw, System 1 learns from it, corrects the flaw, and tries again. They just keep competing in multiple rounds until the video is so hyper-realistic that it can easily be used for fraud or malicious deception.
Section 5. Adapting to an AI future. So, when we strip away all the sci-fi fantasy, we see the real threats very clearly. We aren't fighting self-aware robots, we are fighting human misuse. The true dangers are fraud through deepfake manipulation and the subtle influence on the general public toward specific political orientations or ideologies through curating algorithms. AI is an incredibly powerful tool, but like any tool, its impact depends entirely on the hands that wield it.
But here's the reassuring part. As a society, we have been here before. We have a long track record of surviving massive technological disruption. In the 19th century, people were absolutely terrified of electricity and industrial machines taking away their livelihoods. In the 20th century, the rise of computers brought the exact same fears of widespread job losses. Now, in the 21st century, we're facing the fear of artificial intelligence. And, just like before, humanity will adapt, the nature of work will shift, and entirely new types of jobs will be created. Which leaves us with this final, crucial question to think about as we wrap up. Artificial intelligence probably isn't going to become a supervillain, and it really isn't going to directly take your job. But will someone who takes the time to learn and use AI effectively outcompete you? The future belongs to those who learn to work with this technology, rather than hiding from it. Thank you so much for joining me on this explainer, and keep exploring.